Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hey, hi everyone. How are you all doing today? Hey, hello Adarsh. Hi Shubham. Hi Jatin. Hi Ashish. Okay, can you guys just quickly comment in the chat section if my voice is audible and if my screen is visible to you all? Hello. Thanks Ayush. Thanks Shubham for confirming. Hi Kanik. Hi Shu. Okay, let's just wait for a couple more minutes, all right? Our fellow friends will join and then we shall be starting. Till then, everyone, please comment in the chat section. How are you all? Hi, Sneha. All right, everyone, please write in the chat section like what is your current streak for now. You know, it is day 18, and congratulations to you all for making it till this far. It's a very big achievement. You guys have been consistent till so long. All right. No issues. You can pick up from today, Sneha. We are starting with a new concept. It's not a problem. And you can cover those topics later. Videos are always there in the channel, so you can cover those topics later. All right, guys. So I think we are good to start with today's session. Okay. So, yes, let us start with our first question of the day. As always, we are going to solve three questions, right? So this is our first question, which is minimize the sum of product. All right. Now let us see what the question statement reads. You are given two arrays A and B of equal size n. The task is to find the minimum value of A of 0 into B of 0 plus A of 1 into B of 1 and so on till A of n minus 1 into B of n minus 1, where shuffling of elements of arrays A and B is allowed. Okay, so what is the meaning of this question statement is that we are given two arrays, right? As you can see in the example, two arrays are given to us, right? 311 and 654, and we need to find the maximum sum. Okay, what is the maximum sum? Means you have to multiply the corresponding elements, right? Elements at the same index, means 3 or 6, 1 and 5, 1 and 4. You have to multiply it, and you have to do a multiplication in such a way so that we can get the maximum sum of those multiplications. Okay, so that's what the question statement reads. Let us try to understand our examples. Okay, so array 1 is 311 and we have B as 654, right? We confirm, and yeah, maximum is given as 23. Okay, so these are the two arrays which are given to us. All right, I'm very happy to see the answers. Like, you guys are really working hard on these questions. Okay, so is there any brute force approach that is coming in your mind, first of all, to start with? Okay, any brute force approach? I mean, this can be the thing, that we can multiply 3 with all the elements. Or first of all, see, as it is saying that maximum, we have to maximize it. Okay, so the first thing which comes in mind sometimes maybe, to just multiply the two maximum elements, in that way we can get the maximum product. So that's not the correct intuition. Okay, we need to build our intuition that what question is demanding. Hi, Meshkat. Okay, so see, the question here is demanding is so the question is saying that we need to, okay, sorry, we need to minimize the sum of product. All right, like we need to do it in such a way such that we get the minimum sum. All right, so yeah, tell me here in what way we can get the minimum sum here. Okay, so this question is not a very hard level question, I guess. Check with all the pairs. Okay, yeah, that's a brute force approach, correct. But then that's quite time taking, right? We need to minimize SOP. All right, so okay, I want everyone in the comment section by multiplying maximum and minimum. Okay, and -1. Okay, everyone, please in the chats section comment that what is the first thing which is coming in your mind. Okay, sort both the arrays. Okay, Bharat. Come on, I want everyone to answer this, right? That what is the first thing that you all guys think that we need to do to minimize this sum of product? Okay, tell me one thing here. Two arrays are given to us. Okay, just tell me if one array has been there, say 1, 10, 9, 2, 4, 7, 6, and we need to minimize, we need to do the same thing for the single array, then what we would have done? If there would have been a single array, then what we would have done to minimize the sum of products? Great, Sneha. That's the right answer. Yes, Rish, that's a correct thing that we are going to use sorting here. Okay. Okay, so see, that intuition is clear to you all that we will apply sorting. Okay, so yes, Adarsh, that's correct. Okay, so help me with this, that shall we apply sorting to both the arrays or to only one array? Is sorting is to be applied to both the arrays or a single array? Okay, one, both. Okay, maybe one. Okay, Meshkat, both. Adarsh both. Okay. Both, one ascending, other descending. One. Okay, so yes, Devesh, both. Actually, we need to apply the sorting algorithm to both the arrays. Okay, we will be applying it to both the arrays. Okay. Yes, Bharat, Kamal, both of you are right. We are going to apply it to both the arrays, right? So after sorting, our array will become A is going to be 1 1 3, and B is going to be 4 5 6. Okay, now what next? I have applied sorting algorithm. Now what do I need to do the next? After sorting, if we multiply, say we are getting 1 into 4 plus 1 into 5 plus 18. Okay, so this is 4 5 18, which is 27, right? Yes. See, A of I into B of I, if I'm going to do it that way, then I said that I will get my answer as 27. But we have seen that answer is less than 27, means we have to do something to get less than 27, right? Okay, Kamal, Jagan, Rish and Sneha. Okay, all of you are very much correct that what we are going to do is we can use either of the things. Okay, either we can reverse this array or either we can start the multiplication taking this from here and this from here. All right. So let us reverse our second array. This is 113, and after reversing it, it would be 654, right? And then let us perform the multiplication. It will be 6 plus 5 plus 12, which is equal to 23, right? All right. So is this concept clear? What is there and why we have used the sorting and why sorting? See, there are three concepts, all right? First of all, sorting. Second is sorting in both the arrays. And third is reversing the second array. All right. Are all these three concepts clear to you all? Okay, I will explain once more. I will just take another example. Brute force is the approach that is the very first thing that you are going to do without using any efficient algorithm. Okay, like without taking in consideration the time complexities. Okay. All right, so one of our friends didn't understand it, so I will just explain with another example. Let us say, okay, here we are having a second example with us. A is 61954. Let us take another page. Okay, we have array A as 61594. Okay, and then we have array B as 34824. 34824. All right. Okay. So now tell me, first step, as I have said, is first of all, we are going to sort both the arrays. All right. So after sorting, our A will be 1, 4, 5, 6, 9. And after sorting, B will be 2, 3. Okay, what is this last element? 34824. Okay, 2, 3, 4, 4, 8. Okay. Till this part, it is clear, right? I mean, why we are sorting the arrays, like we want to get the minimum. All right. So to get the minimum, we have to either pick the minimum element of the arrays or either do the maximum element of the arrays, right? We are trying to figure out something so that we can get minimum from one array and maximum from one array. Okay. All right. So we have applied sorting on both the arrays. Okay. Now see, after sorting, if you will simply multiply it, say 1 into 2 plus 4 into 3 plus 5 into 4 plus 6 into 4 plus 9 into 8. Okay, if you simply multiply it, what are you going to do? 2 plus 12 plus 20 plus 24 plus 72. All right, this is coming. Uh, Now, this is, of course, not the most optimal answer that we can have. So what we are going to do is we are going to reverse our second array, okay? Rather than multiplying minimum with a minimum and maximum with a maximum, the most optimal way is to multiply one minimum with other maximum, okay? Is this concept clear? Multiplying the minimum of one array and the maximum of the second array, okay? So that's why let us say we are reversing B. So it will be 8, 4, 4, 3, 2. Okay, tell me in the comment section, will it create any difference if I reverse B or if I reverse A? Just think over it. Hi, Rohit. Yes, Meshka, that's the very correct intuition. Great. Okay, so I asked the question that will it create any difference if I reverse A rather than reversing B? Okay, I'm very happy to see the responses. Bharat, Pravar, Kamal, Chaitanya, all of you have given the correct answer, right? So means you guys are able to understand, right, that why we are sorting both the arrays and then why we are reversing it, okay? So it is clear to you all. So after reversing, when you will multiply, you will get the minimized product. You will get the minimized sum of product, okay? Yes, Aditya. Yes, Trish. That's the correct answer. Okay, so give me a quick thumbs up if we are good to go to the coding part. Okay, yes. And before moving to the coding part, you guys said that we can reverse the array, So that's one additional operation that we are doing. So let us try to, cut on it. So can you tell me what is the other option to perform the multiplication and to do the sum without using reverse? Like multiplication. Okay, multiplication we are doing is, see, first step is we are sorting the arrays, sorting both, then reversing one of them, and then multiplying the corresponding elements, means elements at the same index, multiplying elements at same index. Okay, these are the three steps that we are doing. Is it clear? Yes, Kamal, that's the right answer. Yes, Adarsh, that was the right answer there. Okay, so rather than using this reverse function, what we can do is we can simply start. Okay, we can simply start traversing our B from the end. Okay, so we are good to go to the coding part. You can reverse any of the arrays, it will not create any difference. Any of the arrays can be reversed, okay? Okay, so now let us move to the coding part. Say we have our variable here, long and x is equal to 0. Great. Yes, sort in descending order, but then you can't sort both the arrays in descending order, right? One array has to be in ascending and one array has to be in descending, okay? Now let us say I'm sorting this A plus N. Yes, we can do this. For one array, you can sort it in ascending order, and for other array, you can sort it in descending order. Okay, this can be done. All right, we have long and sum is equal to 0. And let us say I'm starting my one pointer from 0 and I'm starting my second pointer from n minus 1. And I will have a while loop while I is less than n and j is greater than is equal to 0. Okay. We will have our sum is this is equal to, okay. Now tell me what shall I write here? Help me with this coding part. I have started traversing one array from the beginning and I have started traversing one array from the ending. All right. That is I is equal to 0 and j is equal to n minus 1. Now tell me what shall I write here? Okay, guys, tell me what will be this part of the code. A of I into B of J, right? Okay, Pravar, Meshkat, Adarsh, yes, you have decremented J, but why haven't you incremented I? I think you missed that part. Yes, Kamal. Okay. All right. So thanks for helping me. Yes, Chaitanya, that's the right answer. Okay. So rather than incrementing and decrementing in next line, I would like to do it all together. B at J minus, and then we will be returning res. Is this clear? The code that I have written? Is this code clear to you all? Yeah. Yes, Adarsh. Now you have written correctly. Yes, Vibha, that's the right answer. And you should also take in mind the update condition. We are inside a while loop. So min into max. Yes, Aditya, that's exactly the thing that we are doing. All right, guys. So great. We have solved this question. Okay, so now has everyone understood this? Give me a quick thumbs up. And also, guys, please do like this video. I want every one of you who's watching this video to give a thumbs up on this. Great, Aditya. That's nice to hear. Yeah, everyone just please go and hit a like button. So, that will be very nice. Okay, so uh, can we move to the next question now? Give me a thumbs up if we are good to start with our next question. Yes, okay, Chaitanya, thanks. Thanks, Trish. Thanks, Pravar. Okay, so now we are good to start with our next question. Thanks, Neha. Thanks, Aditya. So, see, our next question is N meetings in one room. Okay, so the question statement reads as there is one meeting room in a firm. There are N meetings in the form of start I and I. All right, where start I is start time of meeting I and end I is finish time of meeting I. What is the maximum number of meetings that can be accommodated in the meeting room when only one meeting can be held in the meeting room at a particular time? Okay, and a start time of one chosen meeting can't be equal to the end time of the other chosen meeting. All right, so let us understand the question first. Okay. Okay, so let us do this question first of all. I will just add one more page. All right. So we have here examples as start time is 130585. One three zero 585, and we have end time with us as 246799. 246799. All right. Yes, nice, Neha. That's the correct answer that you have given. I'm very happy to see that. Yes, Chirag, you are correct. This question is similar to the railway platform. Actually, see, okay, so I want all of you to tell me what was the similarity between this question and the previous question that we have discussed. There is a similar algorithm in both of them. What is this? One, okay, the name of the algorithm I want that we have used in both of these questions. Okay. Thanks, Abhijit. Thanks, Meshkat, Aditya, Adarsh. All right. So the approach that we have used is greedy algorithm. Okay. So now, okay. So see, the thing is that now we are trying to understand the greedy algorithm approach. Why? Because the understanding of greedy algorithm will lead us to the understanding of DP. Agree, everyone? Okay, because greedy is like it does not take into account any of the conditions. It just simply sort the whatever values are given to you, and then it calculates the value on that basis. Okay, so intuition of greedy is very much important to get the intuition of DP, right? So to maintain that flow, first of all we need to understand these greedy questions, right? The three questions that have been selected for this session are the standard greedy questions, which will help you all to get the intuition, right? So to maintain this flow, it is very necessary that you guys do these three questions in simultaneously. Okay, so that's why these three questions are selected. Is it clear? Like we are trying to build the intuition so that you guys can understand in the next session why greedy leads to DP. Okay, great. So this is start and end that is given to us. All right, so okay, so all right, so now you people as have already done this question, so help me, what is the first step that we are going to do? The first step that we are going to do is, what is the first thing that we can do? See, in this coding, the most important thing is, with practice you should have the practice of revision as well. Okay, like after doing the questions, it is very important that you revise those questions, otherwise you will get out of practice. So just tell me how help me with this question then. Sort end array. Okay, only sorting end array will help? Are you sure the first step is to sort the end array? Because these arrays are like simultaneous, right? I mean, these are together. We can't just sort the end array. Stored pair of start and end. Okay, Pravar, that's the right answer. Yes, Adarsh. Okay, so what is the first step that we are going to do here? Make pairs, right? The first step that we are going to do is make pairs. Come on, guys, you have already done this question, so you must be very clear that what are the first steps that we are going to do. Make pair, is it clear? Okay, it is clear. So first of all, we are going to make pair. Okay, so in this make pair, there is a point how we are going to make the pairs. I mean, is it start comma end or end comma start? Help me out with this. How we are going to store the pairs? Okay, end comma start, right? Okay, so yes, revision of questions is very important, as I said. Okay, that's why this question has been there in the session. All right, so you guys can kind of revise it, the concepts that you have already studied. Okay, it is very important that the questions you are practicing, if you ever see the questions with the same concept again, you should be able to solve that question, right? Otherwise there is no any benefit of practicing the questions. Okay, getting my point? So regarding how frequently you should practice, just make sure that whatever weekly or monthly, like that, you can, on the basis of how much you are retaining, on the basis of that you can do your revisions. All right. uh, okay, Rish, that's not start or end. I mean, first of all, we are going to see, we can put the start first and end later, but in that case you will have to use a comparator. All right, so that's an extra load for us. So let us make a pair for end comma start. It is clear. Okay, so the pair will be 2143. It was 0, right? 60759895. Okay, is this clear, this pair that we have generated here? If we are already pushing it according to end and start, then we will not need to do any sorting based on a comparator, like user defined comparator. Okay, so this pair is clear. Now we have to do the sorting. We can now directly do the sort, right? So sorting will give us 2 1, right? And then we have, was it already in sorted order? 6075. Okay, 246. It is already sorted. I see. 9895. Sorry, 95 will come first, and then it is 98, right? Can be there. Okay, so now tell me how many. These are the meetings that we have. This is the end time, start time, end time, start time, end start, end start, and then start. Okay. Yes. Welcome, Vibha. So just keep practicing questions. As you can see, this is one of the questions that has already been taken in the session. Okay, so which means that you guys must be very much fluent with this question. All right. We don't have to use a multi-map here. Using a vector which is having a pair, all right, of int and int is sufficient for our use. Okay, this will suffice. All right, now tell me what you guys think. How many meetings can take place here? Can we add this meeting? Of course, it's the first meeting. We can add this. Okay. Okay. So now, can we add this meeting here? Is the end time of this? Start time of this meeting greater than end time of this meeting? All right. Tell me. Yes. Okay. So we are adding this meeting in our room, which is 4. Let us say 3 4. Okay. Now, can we add this meeting? Is start time of this meeting greater than end time of this meeting? Yes, Neha, you are very much correct that we will check if it is possible to add or not. Now, what is that condition of possibility? Okay, how are we going to check if it is possible? Okay, now tell me about this. Can we add 06? No, we can't add. Okay. Can we add 75? Can we add 75 inside our vector? Can this meeting take place actually? Okay, and the condition is start time of this meeting should be greater than end time of the last meeting. I want more answers for these questions. Start exactly, Meshkat, you are completely correct. Start time should be greater than end time. All of you should be giving answers to it. Each viewer who is here should be giving answer to this question because it is a revision. So only 3 replies are there. I want more replies for this. Yes, Chirag, you are correct. We will check that if start time is greater than the end time of the last meeting that we have added, right? Okay, so can we add 9-5? Great, Pravar. Okay, can we add 9-5? Tell me in the chat section. No. Okay. Okay, Meshkat. So like you are saying yes, but okay, how are we going to add 9-5? What is the condition for adding a meeting in the room? Okay, Chirag, that's the right answer. We can't add. So for all of those who have answered yes, see, the condition for adding the meeting is start time of the meeting should be greater than end time of the last meeting. So start time of this meeting is 5, right? Which is not greater than end time of this meeting, which is 7. So yes, Meshkat, now you are right. We can't add 9-5. Okay. So that can't be added. But can we add 8-9? Can we add 8-9 in our meeting? Yeah. Okay. Yes, so total there are n, which is 4 number of meetings are there that can take place inside our room. Okay. Just use a different pen. Is this question clear? Is this example clear to you all? Yes, Neha, you are perfectly right. In any moment, only one meeting will be there. Yes, that's right. Okay, we can add 7:5 because see, the end time of this meeting was 4 and start time of this meeting is 5. So as long as start time given is greater than the end time of the previous meeting, we can add it in our room. Okay. Is it clear? Why 7:5 can be added? Yes, yes, Aditya. Start should be greater than end. Means greater than end means the end time of the last meeting that you have added. Okay. Yes, thanks, Aditya. Thanks, Mishkat. Okay, so are we good to go with the coding part? Thanks, Sahil, for confirming. So now let us start with coding part. Okay. Okay, so now I'm not going to do any of this coding. I want you all to help me here because we are already familiar with this question. So, okay, tell me what will be the first line for this. I want you all to help me now. Okay, let me just write it. Let me do the thing till making pair. Okay, so this part is done, right? Okay, so now tell me, what shall I write here? You guys are helping me, right, for this question? What will be the next step? Okay, I want more answers. Okay, correct, Pravar, Sneha, that's the right answer. Okay, so everyone agree to this, right? Why are we doing this? Thanks, Pravar. Thanks, Sneha, for helping me. Okay. Okay, so we are clear on this part. Great. Now, the next step, okay, first of all, what we need to return is, let me declare it here. We need to return the count of the meetings, right? So, initializing it with 1 because one meeting will always be there that can take place. And then we need to initialize a last time. The last time of the meeting. Is this clear what I'm doing? Will be the okay, the sorting part has been done. Now we are moving to our loop part. For in I is equal to 1, I is less than n, I plus plus. Okay, so help me. What is the next step that I shall be doing here? What shall I do here? What is the condition for checking the possibility so that meeting can happen? We have already discussed it, so you all can figure it out. What is the initialize account? Okay, the count initialization has been done, Pravar. Here we have initialized our variable. This is the CTR. Okay. If last is less than meet I dot second. Thank you so much, Sneha. That's the perfectly right answer, and I'm very much happy. But I want all of you to reply to this, right? Because we have done this question. And so we are able to develop the intuition, right? Then what we are going to do is update last. Okay, we have updated the last. So what shall I update last with? What will be the new value of last? What will be the new value of last? Yes, thanks, Pravar. Okay, and the one more thing that we need to do here is, thanks, Neha. One more thing that we need to do here is, yes, thanks, Sahil, Aditya, all of you are correct. Yes, Vibha, that's correct answer. There's one more step that we need to do. Yes, Neha, perfectly right. Okay. Now that's it, and we will be returning our CPR. Okay, so let us see how we perform. Thanks, Sachin. That's right answer. Okay. Great, guys. Problem has been solved successfully. Okay, so everything was correct. Okay, so one thing that I want from you all is, this question you guys are seeing second time. Okay, just honestly in the chat section comment that how many of you feel confident that if this question will come again, you will be able to solve it. Like, I'm again and again emphasizing that revision is very important. Like, solving a question is a thing, but resolving that question is a very important thing. Okay, just write +1. Whoever feels confident that they can solve this question if it will come again ever. Thanks, Neha, for this wonderful response. Okay, I want everyone to please comment on this, like, you guys will be able to solve this question. Thanks, Sahil, Sachin, thanks. Okay, so keep this in mind that revision of the question is important, right? So once you have solved a question, keep in mind that you need to revisit that question, resolve that question again to check if that is retained in your mind or not. Okay, mostly you have to check that if the logic is there in your mind or not. All right, so yeah, that's great, we have solved this question. Okay, so this was a greedy algorithm, right? So, okay, so before moving to our next question, what I want from you all is, we have used greedy approach, and there are some real life scenarios as well, right, where we use greedy approach in our life. Say when we are standing in our school assemblies, teacher sort us according to height, right? So that's a greedy approach there. Students are sorted according to height, and a student with the least height is standing in the front. So in the chat section, can you guys please add some real life scenarios where we use greedy approach? Anything that you have came across or in your day-to-day life? Okay, Sahil, that was you. Standing in the front or at the last? Grocery buying on tight budget. Okay, yes, that's a big thing that we do. Okay, yes, Chirag, that's a nice answer. Okay, Sahil, so you used to stand at front. Okay. Yes, Neha, that's great. We try to save our energy, so we calculate the minimum distance. Okay, at ticket counter. Okay, all right. So you guys can see that how coding are related to our real life as well, right? It helps you to build the logic, okay, which you can implement in your day-to-day life as well. Like, this greedy approach is very much visible. Like, it is very much relatable that how we are implementing it in our real life, as we just saw that there are so many examples. Okay, so give a thumbs up if we are good to start with our next question, which is the last question of the session. Okay, I think there is a problem. Okay, in for loop, what we have done is we are starting from the first element of our vector, right? So what we are doing is, see, what we are doing is this vector that we have here, say we have 1, 2, the pair that we have made, 3, 4, 7, 5, 8, 9. See, this is the pair. Okay, we are iterating these pairs, and then we are checking that if the end time of this meeting is, sorry, if start time of this meeting is greater than the end time of this meeting. Okay, if start time of current meeting, all right, if start time of current meeting is greater than end time of previous meeting. All right, so this is the condition on the basis of which we will be adding meetings in the room, because they have mentioned in the question that only one meeting can take place. All right, so for one meeting to take place, what is the condition? That start time of that meeting should be greater than the end time of the previous meeting. Only then you can add that meeting. So that is what we are doing in this for loop. We are checking that if last time is like if the current meeting end time is greater than the last time of the previous meeting, all right, then we are updating its value, and then also we are updating the count of meetings that can take place. Is it clear? Like we are checking the end time of the current meeting, okay, which is this, sorry, the start time of the current meeting, which is this, that should be greater than the end time of the previous meeting. Okay, only then you can add the meeting. Okay, great. So let us start with our next question, which says a minimum number of points. All right. So given an infinite supply of each denomination of Indian currency, we have point. Okay, I want you all to pay full attention to this question, because this question will help you to understand why we need DP in some cases. Okay, what was the issue with greedy that we have to come up with DP in some cases, right? So just pay attention to this question. We are given an infinite supply of each denomination, and Indian currencies are 1, 2, 5, 10. I mean, these are the currencies, and a target value n is given to us. Okay, so we have to find the minimum number of coins or notes that are needed to make the change for rupees n. Okay, and we have to return the list of the vector that contains the value of coins required. All right, so first example is given to us, which is 43. Let us work on our examples. 43. Okay, 43 is given to us. Okay, and the denominations are safe. We don't need to go till there. 2, 1. Okay, how are you going to make 43 with minimum number of coins? What is the first thing that comes in your mind after you listen to this word minimum? Okay, Bharat, why are you using this condition? End I should be greater than start I. Yes, Chirag, thanks. We'll choose big currencies. Yes, Neha, that's the answer. But I want to know that why that answer. I mean, what was the first thing which came into your mind? Why you just didn't decided to, take a coin of rupees to say 20 number of times, all right, and then 22, 21 number of times it will make 42, and then you can take one rupee coin. Max coin should be taken first. Okay, so max coin was 50. Why we are not taking 50? There is one plus condition with max coin plus the value of that max coin should be great. Others, thank you so much. That should be less than or is equal to n. Okay, less than value. Yes, Chaitanya, that's right. Thank you. Okay, So are you guys able to develop this intuition that what we are doing here, what we are for minimum number of coins, we are choosing max coin with the maximum denomination. Not only that, the value of that maximum denomination should be less than it. Is this clear? Thanks, Chirag. Very good. Is this concept clear to you all? Give a quick +1 or thumbs up. Okay. Thanks, Meshkat. Thanks, Adarsh. Thanks, Neha. Thanks, Sahil. Okay, we have another example here, which is our n is 1000. Okay. So n here is given as 1000. All right. How are we going to make our coins equal to n,000 in minimum using the minimum number of coins? Yes, I will surely summarize again. Let me explain the example too. All right, so that it will help you to get the clear concept. We have to make 1000. What are the minimum number of coins that can make 1000? Let me see if we have 1000 already in the coins. No, we don't. Okay, so tell me. Minimum number of coins to make one. Okay, see the denominations are 500, 200, and then what is after that? 2150. 2100. Okay, these are the coins that we have. We have 50 as well. Okay, 2. Okay, so those who are saying 2, what are those 2 coins that we are going to use? 2,500. Okay, thanks, Mishkat. So we are going to use 2,500 to make our denomination equal to 1000. Okay, so what is the first thing that you all used? Choose the note with the highest denomination. Okay, with highest denomination. And then second, keep it subtracting, right? Keep it subtracting from n. Keep it subtracting from n. Is this 2 steps clear to you? Yes, Kedar. Yes, Sahil. That's right answer. Chirag, Aditya, thanks a lot for helping me with the correct answer. Okay, are these 2 steps clear to you? Great, Aditya. That's nice to hear. Great, Meshkat. Okay, so these 2. Okay, thanks, Adarsh. So we are clear on this part. So now, shall we go to the coding part? Are we good to go to the coding part for this question? Thanks, Aditya. Okay, as I can see, there are various approaches. Let us see. Okay. First of all, we need to have a list of the denominations that we have, right? So let us create an array which will contain the denominations that we have. Yes, Neha, you are perfectly correct. And that is the reason why this question has been selected, so that you people can understand where greedy fails, we need to go for DP. All right. These are the cases where these questions will work fine in certain number of cases. But then as Sneha mentioned this, in those cases, we need to use DP to get the most optimized solution. All right. There are multiple cases like that. So first of all, you should understand that why the need of DP arised. Okay. So what are the denominations? 1, 2, 5, 10, 20, 50, 100, 200, 500, and 2000. Okay, these are the denominations that we have. Okay, now the size of this array is 10, I think so. All right, so now tell me, how shall I start my loop? We are going to have a loop here. First of all, let me declare the answer array, which is vector int ans. Okay, so now tell me, how are we going to start the loop here? For starting the loop, what was the first thing that we did while we were subtracting denominations from n? Just think over it. Okay, is the question clear to you all? Guys, is the question clear to you all? Yes, yeah, that's right answer. We should first check for bigger currency. So from where should we start our loop? From the end or from the starting? Okay, Kamal, thanks. I is equal to, it's TENO, all right. Okay, so for I is equal to n minus 1, right? The size of the array is 10. Yes, of course, you can reverse the array. We just need to start from the highest currency, right? Highest denomination. I greater than 0, I minus minus. Okay, that is what we are going to do. Okay, now what will be the while condition? Yes, yes, Meshkat, Sneha, Aditya, Adarsh, that's right answer. We are going to start our loop from the end. Now, what will be inside the while condition? I mean, when we will be subtracting the value from our denomination, for what thing you will check? This is our target, which is n. How will you decide whether we should subtract it or not? Yes, Chaitanya, that's right answer. Yes, great, Sneha. So we are going to check if n is greater than the current denomination that we are using. Yes, Kamal, you are right, but you just need to add an equal to sign there. Demo is less than n. Yes, Chirag, that's right. Yes, Adarsh, that's right. So while n is greater than the denomination that we are currently using, we will subtract its value, right? And then we will push back the current denomination that we have used. Okay, is this logic clear? Yes, Adarsh, that's right answer. Is this logic clear to you all? Okay. What are we supposed to return? We're supposed to return our vector. Now let us see if we have coded it correct. I'm sorry. Yes, Vishwanath. Thanks for confirming. All right. See, if you use a recursion, you know a stack space is like we have to take use of an extra space, and an extra space is taken up, all right, for the recursive stack. But you can see in this question, no any extra space has been used, right? All right. So if we are able to solve a question with space complexity lesser than any of the approaches, then we prefer that. right? So for this question, rather than using recursion, you can go with this approach because it will help you save some space of the recursive stack. Okay, so problem has been solved successfully. Okay, so is this question clear to you all? Okay, the question is clear. All right. Now, okay, what is the space complexity of this question? Thanks, Adarsh, for confirming that you have 100% clear this question. Space complexity, no any extra space have been used. All right, so that's a constant space complexity and it's a linear time question. All right, time complexity is linear. For this question as well, okay, what is the time complexity and space complexity of this question? The time complexity and space complexity for this question. We go off one for what? And log n for sort, right? And space complexity is linear. That's correct. So yeah, if it is taking n log n and n, so we say that the time complexity is n log n. All right, the higher time complexity is considered. Okay, great. And the time complexity for this and space complexity as well. Yes, Adarsh, linear for space, right? Aditya, right answer. Okay, so for this question, n log n. Okay, yes, Meshkat, right? Because we have used sorting algorithm, right? So that's why the complexity is n log n, and the space complexity is. Yes, Adarsh, thanks. And log n and constant. Okay, so when I have asked that where I use the greedy approach, I was expecting one answer. Like whenever we write a code, right? There we also use a greedy approach. We try to write a code with a minimum time complexity and space complexity, right? We do that. So that is also one place where we use greedy approach. We try to minimize our space complexity. We try to minimize our time complexity. Okay. Okay. So, all right, that was all about today's session. The one thing that I want you all to emphasize is that please emphasize on revision, right? Revision of question is very necessary. There are some cases, when when you are solving a question for the first time and you are able to do it, but when you will do it for the second time, say, some of the logic you might forget. So it is very necessary that keep on revisiting the questions. Okay, that is important part for the preparation. So, and this is the sheet. I hope you all are accessing this sheet, right? You all are doing questions from the sheet. So every day we will solve the questions from this sheet in chronological order, right? So that is there. And yeah, how was the session? Any confusion, any queries, please do write in the chat section. Yes, thanks, Shishir. Thanks, Meshkat. Okay, so yeah, thanks, Neha. Thanks, Pravar. All right, so now you guys are able to develop the intuition for greedy, right? That in which session we are going, in which questions we are going to use greedy algorithm, right? You must keep that in mind. And also in coming days, we will be seeing that in which questions we need to use DP in place of greedy. Okay, so that we are going to do in coming days. Just keep up this enthusiasm, keep up doing the questions, and keep revising the questions. Okay, that is very important. So thanks for attending it. See you all tomorrow. Bye. Good night.